There's no better way to start this conversation than by providing a high-level overview of what exactly we're talking about with all of this storage talk. We want to talk about what it means to have direct attached storage versus network attached storage versus a storage area network. There's some key differences in protocols that we're going to use and be talking about and referencing throughout not only this skill, but many skills to come. Let's start off with this overview and then we can dive even deeper. Let's jump in. Once upon a time in our data centers, we had servers and we would install our hard drives, our disks, directly into them. And so we typically draw disks looking something like this, a little cylinder. And the CPU is inside the server and it needs to access the hard drive in some fashion. Well, a standard was developed around this, and the protocol that was developed is known as Small Computer System Interface, otherwise known as SCSI. And typically we'd use a cable to connect our storage into our motherboard. And so we had a lot of different options throughout the years. For example, we had IDE connections, we had SATA, we had SAS. Nowadays we use this great protocol called NVMe. And so this was a great solution that lasted a long time. And we called it Direct Attached Storage, otherwise known as DAS. Now this solution worked well enough for a time, but we ended up finding that we had two different problems to solve. First of all is this concept of efficiency. If I had 3 different servers in my environment, and let's say I have local storage in each one, maybe 1 terabyte of storage on each server. Well, what if I have one server that's at 95% capacity, and I think, oh man, I'm almost out of storage. And I look at my other servers, except those other servers are at 10% and maybe 15%. And I'm thinking, well, wait a second, each one of those servers has a terabyte of storage in there. I'm sitting on 900 gig here, I'm sitting on 850 gig here, and I'm almost out of space on this top server. This is an inefficient use of my storage space. By deploying 1 terabyte and 1 terabyte and 1 terabyte, I've effectively deployed 3 terabytes, but I've locked the access to those terabytes within a single set of hardware. Now the second problem is sort of an efficiency problem as well, but it's also a resiliency issue. The idea here is that if I want to protect my disks, I'm typically going to deploy a protocol known as RAID. And the idea of RAID is I can take a cluster of hard drives, and maybe I have 3 different hard drives in one server, and I can deploy one of these as what's known as a parity drive. The parity drive can be used in the event of a failure to restore the lost data. So for example, I lose this hard drive in the middle, well then my RAID driver can actually pull the information using what we have here and what we have on the parity drive. Now without going into a whole lot of details around RAID, the problem here is that if I'm going to do this in a single server, okay, so I lose a hard drive because I can't use the parity drive to store actual data. But the problem with this is as I multiply this out across maybe my 3 servers again, well now when I look at it, I'm losing 3 separate hard drives for parity. So it does again come back to efficiency, but it's also this conversation now that I have to make sure that I'm actually deploying the resiliency my data center needs and not erring on the side of being more efficient. So the industry came up with a solution. Let's group all of our hard drives together in one physical location, and we will call this a storage array. And this storage array will be accessible via the network. That means I don't have to have the hard drives inside my servers anymore. And so not only does this improve my efficiency and my resiliency, but it also allows me to deploy a lot of advanced storage features, such as data reduction across my entire data center. And so this solution is still in effect today. We still use network-based storage arrays in our modern data centers. And we have 2 different types of network-based storage. We have what's known as file level, and we have block storage, which we'll get to in a moment. Now, file level storage is going to be shared, meaning that it can be accessed by many different PCs on the network at once. This is going to work over any standard TCP/IP network, and all of the different PCs that are going to access it are given equal rights to it, meaning that lots of devices can access the file level storage at the same time, and not one of them owns it. So we have no ownership of the file level storage by any particular PC or server in the environment. So for example, I might have file level storage access here on the network, and I've got a lot of different PCs or possibly servers that are accessing the file level storage at one time. However, there are some limitations to this because none of them actually owns this particular block of storage. The first issue is I cannot boot off of a remote file level storage device, at least in most cases. There are some exceptions to this, but for the most part, generally speaking, we're not going to be booting off of it. Second of all, we're not going to install an operating system, which really is what we're talking about with a boot drive, but just to make the point clear, I have to have all of this locally stored on these machines, or have some other kind of access, which we will get into here in a few moments. Now, there are 2 primary protocols within the file level world. We have CIFS, and we have NFS. CIFS is a Windows protocol, and NFS is Linux. And that is basically the distinction between these protocols. I mean, we could drill into the details and really note the differences, but for the most part, if you're on a Windows device, you're going to want to access a file share via CIFS. Likewise, if you're on Linux, you're going to want to access the file server via NFS. Now, this entire paradigm is known as Network Attached Storage, otherwise known as NAS. This is in direct contrast with Direct Attached Storage, or DAS, which we talked about at the beginning. Now, the other option we have available to us is known as block-level storage. Block-level storage is dedicated storage. It is actually going to be owned by a particular PC or server in the environment. So I can put my storage out on the network. I can have lots of different devices out on the network, again, PCs, or in this case, likely servers. But only one server is able to access it at a time. If for any reason another device tried to go and take ownership of it, we might as well have plugged over here in the DAS world this hard drive into 2 different servers at the same time via a SCSI connection. It's going to cause corruption. It's going to cause all kinds of issues. And so it's less flexible from that perspective. However, it also allows us to solve some of the problems we just talked about. We can boot from these block level storage devices, which means that we can also install our operating systems. We don't have to have a local boot device just to get fired up and then access our storage remotely. Now, there are 3 main protocols for accessing block level storage. We have the concept of iSCSI, Fiber Channel, and Fiber Channel over Ethernet. iSCSI is going to rely on TCP/IP. It's actually what the little I stands for at the start of iSCSI. It's a reference to the IP protocol. As such, it can use our existing network switches. However, in a lot of cases, for resiliency's sake, we might have a pair of servers here and they have normal network access this way down to the users, but then we might actually have a back-end iSCSI network and hang the storage off of that. That way we don't have risks of spanning tree loops and all kinds of other bad situations that we get if we have dedicated physical switches for the iSCSI network. However, this isn't strictly required, and as such, we could actually get rid of the back-end network and simply connect our storage array to the traditional network. That way, even though we do have user traffic coming in and out on those interfaces, we could also access our storage in the same way. Now, Fiber Channel, this is going to require special switches. Cisco actually has a line of switches known as MDS switches, which are dedicated to Fiber Channel. Fiber Channel Ethernet, they're like oil and water. We can't actually run Fiber Channel directly over a standard TCP/IP network. Now, Fiber Channel over Ethernet, you might have decided, is indeed capable of running over Ethernet switches. However, these Ethernet switches must be specially designed for Fiber Channel over Ethernet. In other words, they must run a standard set of protocols that are required to run FCOE. We cannot simply send FCOE frames across a traditional Ethernet network. We need a whole lot of special attention given to these frames, and we'll see that later on. Now, these protocols down here, these block level protocols, when we're deploying them, this is known as a storage area network, otherwise known as a SAN. And so every now and again, when you're interfacing with your server or your storage folks, you might hear them refer to the SAN or possibly to the NAS. And what they're really saying is that we're running 2 different types of storage. We're running storage area network, that would be a block level protocol like iSCSI, Fiber Channel, or FCOE, or they might be referring to a network attached storage device, maybe called a NAS or a NAS box, and that would be running file level protocols. So as we discussed, traditional architectures were built on that idea of direct attached storage, otherwise known as DAS. And for the efficiency and resiliency reasons we saw, we decided to take the hard drives and the disks out of the servers and put them onto the network. We have 2 different options here. We have file level protocols such as CIFS and NFS that we talked about. That allows many different PCs and servers to access the storage at once. It's a shared environment. However, if we need dedicated storage, like we want to boot off of it or install the operating system, completely wipe the device for that matter, that would be where block level protocols come in. They're going to offer our servers dedicated access so that we can do all of those things that we talked about. And again, the primary protocols there will be iSCSI, Fiber Channel, or Fiber Channel over Ethernet. I hope this has been informative for you, and I'd like to thank you for viewing.